Hello students, welcome to my channel Avin Tricks. This is video number 2 on haloalkanes and haloarenes. In this video, we are going to see the NEET and JEE level questions related to nomenclature of haloalkanes and haloarenes. If you go through the previous year question papers of JEE or NEET as well as board exam, you will come to know that the examiner have set the question papers many times by using the common names of haloalkanes and haloarenes. At the same time, in many question papers, you will also come to know that the examiners, they have set the question papers using the IUPAC names of haloalkanes and haloarenes. This tells us that we should be very perfect and we should be thorough in naming of haloalkanes and haloarenes in both versions, that is in common system as well as in IUPAC system. In this video, I am going to explain you in detail how the common names can be given to haloalkanes and how IUPAC names are given to haloalkanes as well as haloarenes. If you are preparing for JEE or NEET, then it is mandatory, it is compulsory, it is must that you should be perfect in nomenclature in common name system as well as IUPAC name system in haloalkanes and haloarenes chapter. Here we go. In nomenclature, first we learn common name system, then we go for IUPAC name system. Let us see the nomenclature of monohalogen derivatives first. Monohalogen means they contain one halogen atom in their molecule. The common name for monohalogen derivative is alkyl halides. First we have to name alkyl groups, then we have to end the name with halide. So let us see what is an alkyl group and then let us see what are halides. When alkanes lose one hydrogen atom, they become alkyl. This is the symbolic representation of alkane, RH. When alkane lose one hydrogen atom, it becomes what? R. This is called as alkyl group. This is called alkyl group. When this alkyl group has one halogen atom, it becomes RX. This is called as alkyl halide. Alkyl halide. Let us take few examples of alkyl groups. Methane, when it loses one hydrogen atom, it becomes CH3. This is called as methyl. When this methyl group is present with halogen like fluorine or chlorine, bromine, iodine, its common name becomes methyl fluoride, methyl chloride, methyl bromide, methyl iodide, etc. Let us take the second member, that is C2H6. This is ethane. When ethane loses one hydrogen atom, it becomes C2H5. This is called as ethyl. This is called as ethyl group. When this C2H5 is associated with fluorine, then it becomes ethyl fluoride, ethyl chloride, ethyl bromide, ethyl iodide, etc. This ethyl group, many times it is also written as CH3CH2. We can write ethyl group in short C2H5, or we can also write ethyl group as CH3CH2. These two examples, methane and ethane, they tell us that they have only one type of alkyl group. Methane has only one type of alkyl group, that is methyl. Ethane has only one type of alkyl group, that is ethyl. When we go for higher alkanes, we will have more than one alkyl group for them. We can have two types of alkyl groups for propane, because propane has two types of hydrogen atoms. If one hydrogen atom is replaced from this terminal carbon atom, then we get N-propyl group. N means normal propyl. If we remove the hydrogen from the second carbon atom, then we get isopropyl group. Isopropyl. If halogen atom is present on the terminal carbon atom, then we name it as N-propyl halide. If chlorine is there, we call it as N-propyl chloride. Bromine, N-propyl bromide. If iodine is present, we can call it as N-propyl iodide. If the halogen is present on the second carbon atom, we call it as isopropyl. So if chlorine is present on second carbon atom, we call it as isopropyl chloride. If bromine is present, isopropyl bromide. If iodine is present on second carbon, we call it as isopropyl iodide. And symbolically, with bond line diagram, we can show the propane symbolically with bond line structure like this. And this position, if you remove this position hydrogen and if you attach halogen here, that is called as N-propyl. The compound is called as N-propyl halide if halogen is attached to terminal carbon atom. If hydrogen is replaced from this carbon atom and halogen is attached here, it is called as isopropyl halide. Isopropyl. In this way, in propane, we have two types of alkyl groups. First, N-propyl and another one is isopropyl group. One more point I will explain here only. When the hydrogen atom is removed from second carbon atom, why we call it as isopropyl? Because iso means same. When we have substituent on middle carbon atom, left side and right side groups are same. Therefore, it is called as iso. When left side and right side groups are same, methyl groups are present. Therefore, that is called as iso. Iso means same groups when they are present at left side and right side, we call it as iso. Therefore, this is isopropyl. In case of butane, we can have four types of alkyl groups. This is butane. If hydrogen atom is replaced from the terminal carbon atom, then we get CH3, CH2, CH2, CH2. This is called as N-butyl group. N-butyl group. If halogen is present, then it is called as N-butyl halide. If chlorine is there, N-butyl chloride. Bromine, N-butyl bromide, so on. In this case, the hydrogen atom is replaced from second carbon atom. Then we have CH3, CH2, CH, CH3. This is called as secondary butyl group, or in short, it is called as sec-butyl. See, here if halogen atom is present on second carbon of butane, then it is called as sec-butyl halide. If chlorine is there, then we call it as sec-butyl chloride, bromine, sec-butyl bromide, and iodine, sec-butyl iodide, so on. This is the third case of butane. Butane may also exist in this form, and if the hydrogen atom of this carbon atom is replaced, CH3, CH, CH2 and CH3. If the hydrogen atom of this carbon atom is replaced, if you observe this, left side and right side groups are again same. This is called as isobutyl. This is called isobutyl. If halogen atom is present on this carbon atom, then we call it as isobutyl halide. If chlorine, isobutyl chloride, so on. In last case, the hydrogen atom of this carbon is replaced. So we have CH3, CH3 and CH3. This hydrogen is replaced. This is called as tertiary butyl group. This is called tertiary butyl group. And if here bromine is present, then it is called as tertiary butyl bromide, chlorine tertiary butyl chloride. And tertiary, the word is shortened to tert butyl. This shows that the alkene containing 4 carbon atoms can exist in 4 different alkyl groups: N-butyl, sec-butyl, isobutyl and tertiary butyl. Now I will give you symbolic representation and trick for this. 4 types of butyl groups can be easily understood by taking the bond line formula. We can show this butane by using bond line formula like this. Here first carbon, second, third, fourth. If the hydrogen from this carbon is replaced, then we call it as N-butyl. If the hydrogen from second carbon is replaced, we call it as sec-butyl. When the carbon atoms are present in this way, when hydrogen from this carbon is replaced, we call it as isobutyl. And in this case, if the hydrogen is replaced from this carbon, then we call it as tertiary butyl. In case of pentane, we have normal pentyl group and all other pentyl group, and one most important pentyl group is neopentyl. When the 5 carbon atoms are present in this manner, this is called as neopentane. When one hydrogen atom is replaced, if you see all these methyl groups, they are equivalent. You can replace the hydrogen from this or this or this or this CH3. It is same. Therefore, you will get a group like this. This is called as neopentyl. I have replaced the hydrogen from this carbon atom. This is neopentyl. And the hydrogen where it is replaced, when halogen atom is present, say chlorine, it becomes neopentyl chloride. Now I summarize all types of alkyl groups. In case of propane, we have 2 types of alkyl groups. This is bond line structure of propane. In case of propane, we have 2 types. This is N-propyl, and if the substituent is present here, it is called as isopropyl. In case of butane, we have 4 types. If substituent present here by replacing hydrogen, it is called as N-butyl. If the hydrogen is replaced and substituent present, that is halogen present on this carbon, it is called as secondary butyl or sec-butyl. And in this case, if the substituent present on this carbon or this, it is called as isobutyl. And in last case, if the substituent present on this carbon atom, it is called as tertiary butyl. So take the screenshot. Now let us see the common naming in case of dihaloalkanes. They are of 2 types. They contain 2 halogen atoms. When 2 same halogen atoms present on the same carbon atom, it is called as geminal dihalide. I repeat, when two same halogen atoms present on the same carbon atom, it is called as geminal dihalide. When same halogen atoms present on the adjacent carbon atom, they are called as vicinal dihalides. When same halogen atoms, they are not present on the same or adjacent carbon atoms, they are present anywhere in the molecule, it is called as isolated dihalide. And when the two same halogen atoms present on the terminal carbon atoms, bromine is present here and another bromine is present on another terminal carbon atom, it is called as methylene dihalide, because CH2 group is known as methylene group. How many CH2 groups are there? 1, 2, 3, 4. Therefore, we can call it as tetramethylene bromide. We can call it as tetramethylene bromide. Now, we will learn in detail the common naming in case of geminal dihalide and vicinal dihalides. Here we go. Dihaloalkanes in which two same halogen atoms are present on the same carbon atom, they are called as geminal dihalides. Common name for geminal dihalide is Alkylidene halide. Geminal dihalide is group name. Its common name is Alkylidene halide. Let us consider one example, CH3CHClCl. Here the alkyl group is Ethylidene. Ethylidene chloride. If we consider this example, if you see here, the 4 carbon atoms are there and one branch is there. This is isobutyl. Isobutyl. Therefore, this becomes isobutylidene iodide. And this is exception when two halogen atoms are present on the single carbon atom, that is, as in case here, we should not call it as methylidene chloride. It is wrong. Its name should be methylene chloride. Methylene chloride is correct common name for this. This is exception. Common naming in case of vicinal dihalides, when two same halogen atoms, they are present on adjacent carbon atoms, means side by side carbon atoms, it is called as vicinal dihalide. It is a group name. Its common name is alkylene halide. Here we have CH3CH, CH2 and two iodine atoms, they are present on adjacent carbon atoms. Therefore, what is the alkylene group here? 1, 2, 3. 3 means propylene. Propylene iodide. This is the common name for this compound. If you see here, this group is isobutyl group. So it becomes, according to this, isobutylene. Isobutylene chloride. Now let us see the common naming in case of isolated dihaloalkanes. If we see this example, two same halogen atoms, they are present on different carbon atoms. Therefore, its common name becomes isolated dichloro. Total there are 7 carbon atoms, therefore it becomes heptane. The common name of this compound is isolated dichloroheptane. Now last, polymethylene halide. Here how many methylene groups are there? 1, 2, 3, 4, 5. And we know that in polymethylene, the two same halogen atoms, they are present on the terminal carbon atoms. Therefore, there are 5 carbon atoms. Therefore, we can say pentamethylene bromide. This is the common name for this compound. IUPAC nomenclature for halogen derivatives is haloalkanes. First, we have to name halogen atom with its short form. If chlorine is there, we have to call it as chloro, bromine, bromo, iodine, iodo, fluorine, fluoro. Then we have to write the complete name of alkane. Halo plus complete name of alkane. This is the IUPAC nomenclature of halogen derivatives. For example, CH3, CH2, Br. If I want to write its IUPAC name, I have to write halo group first. That is, bromine is there. So, in short, we have to write bromo. Then, what is the name of this alkane? Alkane containing 2 carbon atom is ethane. Bromoethane is IUPAC name of this. One more example I take here. CH3, CH2, CH2. See, on second carbon atom, chlorine is present. We have to number this chain near from the halogen atom. 1, 2, 3, 4. Then the halogen atom is substituted to second carbon atom. We have to show the position of halogen atom, that is 2 chloro. Total 4 carbon atoms are there. Therefore, the alkane is butane. IUPAC name of this compound is 2-chlorobutane. Now, let us see the nomenclature in case of haloarenes. Common name and IUPAC name are same. In haloarenes, common name as well as IUPAC name are one and the same. If more than one halogen atom is present, in common naming, we use ortho, para, meta, these words to indicate the position of the atoms. And in case of IUPAC, we use numbers to show the position of the atoms. For example, if I take this, common name is chlorobenzene, IUPAC name is also chlorobenzene. In common naming, the positions of carbon atoms on benzene ring are represented by para, ortho, and these positions are named as meta positions. And in IUPAC system, the carbon atoms are numbered by 1, 2, 3, 4, 5, 6. Let us take one example. When more than one halogen atom present on the benzene ring, in common naming, we make use of ortho, para and meta. Here, this is meta position. So, we write meta dichlorobenzene. If we want to write the IUPAC name of this, we have to number 1, 2, 3, 4, 5, 6. So 1, 3 dichlorobenzene. This is the IUPAC name of this compound. Let us take one more example. If we have bromine, here another bromine, here one more bromine. According to the common name system, it is named as symmetric tribromobenzene. This is common name, and if we want to write the IUPAC name 1, 2, 3, 4, 5, 6. So 1, 2, 1, 3, 5. 1, 3, 5 tribromo benzene. These are the common name and IUPAC name methods in haloarenes. Now we will take a series of examples. Here we go. Now let us take few examples, few structures, and we will write their common name and IUPAC names as well. And I will also show you how in competitive level exams like JEE, NEET and many other exams, how they frame questions on nomenclature. I will show you with proof. The first example, this is the structure given. So we have to write common name as well as IUPAC name. First, it is better to write in bond lines form. There are 4 carbon atoms. I have shown 1, 2, 3, 4 carbon atoms like this, and on second carbon atom there is substituent. This position we have already learned. This is secondary position. Therefore, this is secondary butyl chloride. Its name becomes secondary butyl chloride. And according to IUPAC, we have to number the longest carbon chain nearest to halogen. So 1, 2, 3, 4. This is the longest chain. On second carbon atom there is halogen. Therefore 2-chlorobutane. The name of this compound is 2-chlorobutane. Now if we write this bond line structure, it is like this, and chlorine is present on this carbon atom. Chlorine is present on this carbon atom. Therefore, this is isobutyl. So, this is isobutyl chloride. And we have to number the longest chain, that is 1, 2, 3. On second carbon atom, there is methyl group. On first carbon atom, there is chlorine. Alphabetically, chlorine comes first, then methyl. So, 1-chloro, 2-methyl. The chain is of 3 carbon atoms, therefore it is propane. So the name of this compound is 1-chloro, 2-methyl propane. Now let us take the next one. And this, if we write bond line structure, it becomes like this. And this is a neopentyl because the halogen is present on this carbon, means this 5 carbon atoms are there, 1, 2, 3, 4, 5. Therefore, this is neopentyl group. So, we can write here neopentyl bromide. The common name is neopentyl bromide. Then IUPAC name, longest chain is 1, 2, 3. This is the longest chain. On second carbon atom, there are 2 methyl groups, and first carbon atom, there is 1 bromine. According to alphabetical order, bromine comes first. So, its name is 1-bromo 2,2 dimethyl propane. The name of IUPAC name of this compound is 1-bromo 2,2 dimethyl propane. Now, common name of this is the halogen is attached to the carbon having double bond. Therefore, this is vinyl group. So, its name is vinyl chloride. And its IUPAC name is 1, 2. That is chloroethene. its name is chloroethene. This molecule is very important because we are going to use this molecule in SN1 reaction. So its structure is like this, and bromine is attached to here. Therefore, this group is tertiary butyl group. Therefore, the name is tertiary butyl bromide. And IUPAC name is, longest chain is this one, 1, 2, 3. Therefore, second carbon has one bromine substituent and here methyl substituent. Therefore, we can call this as 2-bromo 2-methyl propane. The name of this compound is 2-bromo 2-methyl propane. We have to write in a continuous manner, but due to some space problem, I have written one below another. You have to write without space. You have to write in a straight line, right, in a continuous manner. The IUPAC name of this compound is 2-bromo 2-methyl propane and its common name is tertiary butyl bromide. And in my first video, I have explained when the halogen is attached to that carbon which is next to carbon-carbon double bond. This is called as allylic. Therefore, the name of this compound is allyl bromide. Allyl bromide. And while giving the IUPAC name, we should number the carbon chain by giving preference to double bond. So 1, 2, 3. So the double bond is near to left side. So we have started numbering from left side. Means double bond should get minimum number. So what is the name of this? 3-bromo 3 carbon atoms prop 1-ene. The IUPAC name of this compound is 3-bromo prop 1-ene. Here 1 indicates from which carbon atom double bond starts. The common name of this compound is benzene and CS3. This is considered as a parent, that is called benzene with CS3. It is called as toluene, and this position is ortho position. Therefore, in common naming, it is orthochlorotoluene. And according to IUPAC, the alphabetically chlorine first and then methyl group comes. Therefore, its name is 1-chloro 2-methyl benzene, or if we consider benzene and CS3 group as a toluene, then we start numbering from here 1, 2. Therefore, 2-chlorotoluene. 2-chlorotoluene. This is the another name. Both names are valid for this compound. This example is present in the NCERT book. From this example in 2017, a question was framed in JEE Advanced like this. Its common name becomes, this is para position with respect to CS3. Therefore, this is para-chlorotoluene. And IUPAC name, we have two methods. We have we have two IUPAC name for this. If we consider the chlorine and methyl group are substituent of benzene, we have 1-chloro. This is 1, 2, 3, 4. 4-methyl benzene. Another name is, if we consider this is the product of toluene. So this is 1, 2, 3, 4. 4-chloro toluene. Both the names are valid. In competitive JEE advanced exam, they asked what is the IUPAC name or names of this compound. So there are two names, 1-chloro-4-methylbenzene or that is 4-chloro-toluene. From this, it becomes very clear that if we are perfect in NCERT book, the competitive level questions will arise from the examples and the questions given in the NCERT book. They modify slightly and they ask question in competitive level exams. So this is the best example that in textbook it was given like this and they framed a question in competitive level like this. If we know the naming, common naming as well as IUPAC naming of this compound, if we know the concept, and easily we can answer for this question. Now let us solve few questions. Write IUPAC name of this structure. When they give structure and they ask us IUPAC name, the first thing we have to do is we have to write it in a simplified manner. That is, I write in a simple manner. This is CH double bond CH and this is CH and I write here CH3 and this is substituent of this carbon atom. And we should start numbering from the side which is near to multiple bond. When multiple bond is present like double and triple bond, we should begin the numbering of carbon atom near to double bond. So 1, 2, 3. See here double bond starts. If we write numbering from 1, 2, 3 like this, double bond begins from second carbon atom. If we start numbering from here 1, 2, 3, double bond starts from third carbon atom. We should go from that end where the double bond starts first or where the double bond becomes near. 4, 5. This is the longest chain. So on fourth carbon atom there is chlorine. Therefore 4-chloro. How many carbon atoms are there? 5. 5 means pent. And this is alkene. That alkene double bond start from second carbon. So it is 2-ene. This is the IUPAC name, 4-chloro-pent-2-ene. In this example, CH2 double bond. See, this is the substituent CH. I write CH3 here and Cl here. We have to start numbering from left side because the double bond is close to left side. So there are two substituents, chlorine and methyl group. Chlorine, alphabetically C comes first. Therefore, I should write 3-chloro. The second substituent is 2-methyl. Total 4 carbon means but. Double bond starts from first carbon, so it is 1-ene. The name of this compound is 3-chloro-2-methyl-but-1-ene. Now, the next question we will take, write the structural formula. They have given some common name as well as IUPAC name. The first question is secondary butyl chloride. We have already seen that secondary butyl, it is like this, means when the hydrogen atom of this second carbon is replaced by halogen, we get secondary butyl, and it is replaced by chlorine. Therefore, this is secondary butyl chloride. And if we want to write the expanded full form of this structure, how we can do? Here 4 carbon, butyl means 4 carbon, we have to show like this, and on second carbon atom there is chlorine, and here we have to see this carbon has how many single bond? It has only one bond, and from 4 we have to subtract 1, remains how many? 3. We have to give 3 hydrogens. This second carbon, it has 2 bonds, out of 4 subtract 2, so 2 remains, so it has 2 hydrogens. And this carbon atom has 3 single bonds, out of 4 subtract 3, remains 1, so it has only 1 hydrogen. And the last carbon atom has 1 single bond, we have to subtract 1 from 4, it remains 3, and it becomes CS3. In this way we can write the structural formula of given compound, isobutyl chloride. And we have also seen isobutyl means it is like this. When this, from this carbon atom hydrogen is replaced, we get isobutyl, means from this the hydrogen is replaced by halogen. This is the structure of isobutyl chloride. If you want to write the clear structure, it is like this. Here Cl, okay, this carbon, this is isobutyl group, and this carbon has only 1 single bond, from 4 1 is subtracted, 3 remains. This carbon has 3 single bonds, from 4 subtract 3, you will get 1. This carbon has 1 single bond, 4 minus 1 means 3. This carbon has 2 single bonds, out of 4 subtract 2, you will get 2. This is the isobutyl chloride structure. Then allyl chloride, and we know allyl chloride, when the halogen is attached to that carbon atom which is next to carbon-carbon double bond. So this is allylic group. So let us see, here a double bond is present, therefore here 2 hydrogen atoms, and here 1 2 3 means out of 4 3 1 1. So this is the allyl chloride. Then last one, 4-chloro-pent-2-ene. What is the root word here? Pent-2-ene. Pent means how many carbon atoms? 5 carbon atoms we have to draw first. 3, 4, 5. Let's number these carbon atoms from 1, 2, 3, 4 from right to left, and on second carbon atom there is a double bond, okay, pent-2-ene, and on fourth carbon atom there is a chlorine. Now remaining valency should be satisfied by hydrogen. This carbon has only one bond, means 3 hydrogen bonds, and here 1 hydrogen, here 3 means 1 hydrogen, here 3 bonds are there, fourth, and here 1 bond is there, so its valency will be completed by 3 hydrogen atoms. So this is the structure of 4-chloro-pent-2-ene. Now let us take one very important question. Draw 8 structural isomers of formula C5H11Br, give IUPAC names and classify them as primary, secondary, tertiary bromides. Whenever we come across such questions, a formula is given and we have asked to write the structures. First of all, we have to find out, is there any double bond present in this molecule? That we have to detect first. That can be done by finding the degree of unsaturation. Degree of unsaturation can be found out by using the formula 2 into number of carbon atoms plus 2 minus number of hydrogen atoms minus number of halogen atom plus number of nitrogen atoms divided by 2. Now 2 into number of carbon atoms 5 plus 2 number of hydrogen atoms are 11 minus number of halogen atom is 1 and number of nitrogen atoms is 0 divided by 2. If you multiply plus add, it will become 5 plus 2 10, 10 plus 2 12 minus 11 minus 1, that becomes minus 12 upon 2, that becomes 0. This shows that in this molecule there are no double bonds present. Now we can easily draw 8 possible isomeric structures very easily. Here we go. We have to write 8 isomeric structures of this formula C5H11Br. How we can do this is, the first step is we should write possible structures first. The carbon skeleton having 5 carbon atoms we can show like this: 1 2 3 4 5. The second possible carbon skeleton is we have to reduce one carbon atom and we have to make one branch, means 4 carbon atoms, 1 2 3 4, and we make one branch for this. The next skeleton is again we have to reduce from the one carbon from this, means 1 2 3, and we have to make 2 branches. These are the 3 possible skeletons of C5. Now 8 isomers. If the hydrogen atom of this carbon atom is replaced by bromine, we get first isomer. So what is the name of this compound? The bromine is present on this carbon, that is 1-bromopentane. If you see, when bromine is present on this carbon atom, that carbon is attached to only one more carbon atom. Therefore, this is primary alkyl halide. We already know when carbon is attached to one more carbon atom, it is primary carbon atom. When carbon is attached to 2 other carbon atom, it is secondary carbon atom. And if carbon is attached to 3 other carbon atom, it is tertiary. Next, if the bromine is present on this carbon atom, so what is the name, IUPAC name? The longest chain is 1 2 3 4 5, that is 2-bromopentane. And the bromine is attached to this carbon is attached to 2 other carbon atoms. Therefore, this is secondary alkyl halide. The next is when the halogen atom is attached to this carbon atom, that is 3-bromopentane. This also a secondary alkyl halide, because the halogen is attached here, this carbon is attached to 2 other carbon atoms. Therefore, this is also secondary alkyl halide. And in this molecule, 3 isomers are possible. Now, here, if the halogen is present on this carbon atom, okay, let us count 1 2 3 4. So, what is the name? 1-bromo 2-methyl 4 carbon atoms means butane. See, the bromine is attached to this carbon, it is again attached to one more carbon. Therefore, this is primary alkyl halide. Imagine that the halogen atom is present on this carbon atom. Okay, the longest chain is again 1 2 3 4. So the bromine is present on this, that means 2-bromo, and on second carbon atom only methyl group is also present, 2-methyl butane. If you see this carbon, it is attached to 1, 2, 3. 3 other carbon atoms. Therefore, this is tertiary. This is tertiary alkyl halide. If the bromine is present on this carbon atom, okay, the numbering should be done from this end now. 1, 2, 3, 4. So, its name becomes 2-bromo 3-methyl butane. What is the degree of this? Bromine is present on this carbon atom, it is attached to 1 and 2, means secondary. And if the bromine is present on this carbon atom, then we get 1-bromo 3-methyl butane. What is the degree? That is primary. In this skeleton, 4 isomers are possible, and in neopentane, the bromine may be present either on this or this. It is same. Therefore, the longest chain is it is CH2. Say bromine is present here. Okay. What is the longest chain? 1, 2, 3. Okay. So 1-bromo. For second carbon atom, there is 1 methyl, another methyl. 2 methyl groups are substituent. Therefore, 2, 2 dimethyl. Longest chain is of 3 carbon, that is propane. What is the degree of this? The halogen atom is attached to this. This is again attached to one more carbon atom. Therefore, this is primary alkyl halide. They may even ask in competitive exam, C5H11Br contains how many primary, secondary, tertiary isomers. As we have seen that there are 4 primary isomers and 3 secondary isomers and 1 tertiary isomer are possible with the formula C5H11Br. Give IUPAC names of following structures. When the given molecule has multiple bonds, the longest chain is selected which is close to multiple bond. So let us number the longest carbon chain here. This is first carbon, this is second, this is third, this is fourth, and this is fifth. So this is the longest skeleton, and let us see the substituent. Here bromine is there. So bromine is present on fourth carbon. So this is 4-bromo, and 5 carbon atoms are present. That means pent. The double bond starts from second carbon atom. Therefore, it becomes pent-2-ene. This is the IUPAC name of this compound. Now, in this, the carbon starts from here 1, 2, 3, 4, and there are 4 carbon atom in longest chain, and bromine is substituent. It is present on third carbon atom, and here 1 methyl group is also there on second carbon atom. According to alphabetical order, bromine comes first. Therefore, this is 3-bromo. Second substituent is this methyl group. So 2-methyl, and the carbon chain is of 4 carbon. Means but, double bond starts from first carbon. Therefore, but-1-ene. This is the IUPAC name. If you see this example, the counting of longest chain, if we carry out from this end, 1, 2, 3, 4, double bond starts from second carbon atom. And if you start counting from this end, 1, 2, 3, 4. From this end also the double bond starts from second carbon atom. So the preference should be given to that side which has more number of substituent. Here bromine is there and double bond is also at second carbon atom. So the numbering should be done from this end. This carbon is first, second, third, fourth. Therefore the name is 1-bromo 2-methyl 2-methyl but-2-ene. You have to write in a continuous manner. Okay. Next, in this case also the double bond starts from this end also from second carbon, from this end also from second carbon atom. So preference is given to that side which has more substituent. Therefore this is first carbon, second, third, fourth. So 1-bromo. How many carbon atoms are there? 4. But, double bond starts from second, so 2-ene. This is the IUPAC name of. Now let us see few more questions. Write the structure when the name is given. The name is given 2-chloro-3-methyl-pentane. I give you one solid simple trick. We have to see the end part of the name. Here it is pentane. That means we have to draw 5 carbon atoms. I have drawn 5 carbon atoms. 1, 2, 3, 4, 5. You number the carbon atom from any end. Okay. 1, 2, 3, 4, 5. On second carbon atom there is halogen, that is chlorine. Here we have to write Cl. On third carbon atom there is one methyl group, there is CH3. Therefore, this is the structure of 2-chloro-3-methyl-pentane. Now, 1-chloro-4-ethyl cyclohexane. We have to see the end part of this. This is cyclohexane. How we can draw cyclohexane? We can draw cyclohexane like this. And number it from this. 1, 2, 3, 4, 5, 6. Cyclohexane. So, 1-chloro means on first carbon atom there is chlorine. On second carbon atom, ethyl group is there. Ethyl group we can draw like this. Or we can write CS2, CS3. This is the 1-chloro-4-ethyl cyclohexane. The next question is 4-tertiary butyl 3-iodoheptane. We have to write the structure of this name. So we have to see the end part of this, that is heptane. Heptane means 7 carbon atoms. In one of my video, nomenclature video, I have given how to name the alkanes from 1 to 100. Please, you can visit to my channel and you can see that also. That will help you. So there are in heptane 7 carbon atoms. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now on fourth carbon atom, there is a tertiary butyl. Tertiary butyl means what? CH3. This is the structure of 4-tertiary butyl iodoheptane. On fourth carbon atom, tertiary butyl group is there, and third carbon atom, iodine is present, and there are 7 carbon atoms. Therefore, this is heptane. In this video, we have seen the common naming and IUPAC naming of haloalkanes and haloarenes. And in next video, we are going to see the preparation, properties and chemical reactions of haloalkanes and haloarenes. Thank you for watching this video. This is Avin. Please subscribe, share and leave a comment on the video. I'm thankful to YouTube and millions of YouTube viewers.